TTL Computer II. Today we'll be taking a look at our backplane and our rework that we had to do for ALU. So if you've been following my posts, you know that we had uncovered an issue in our ALU testing, and specifically the not carry flag failed our regression test on the backplane. So we're looking at our backplane connector schematic sheet for all of our connectors, and you're going to see check marks on there now on all of these. So they weren't there because I didn't do this. I didn't check this sheet, and the reason why I didn't is because each of these connectors is copied directly from the schematic for the individual cards. And we know that we built out all of our cards and we already tested those on our jig, and we know that everything was correct. So it didn't seem like we really needed to check these a second time against the simulator, but I should have, because even though our prior work on the cards ensured that each of these pin connections on the connectors was in fact connected to its correct signal. But because we didn't do the final comparison of this sheet against the simulator, we weren't guaranteed that the net labels on these pins for this schematic were correct. And in fact, we had an error, right? We had the not carry signal was labeled with the NCO, which was the old not carry out naming convention that I had, but that conflicts um, with the C register out signal, which is NCO. So these were connected together, and whatever, that's an error. Shouldn't be that way. So we need to implement a fix that is going to change this from the NCO net to the not carry net, which is the not carry signal. That's what we'll be looking at today. All right, so I outlined what we were going to need to do, and just back here, we're going to basically need to remove this connector from the backplane. We're going to have to bypass this signal line from going to the backplane, and then we're going to have to hardwire that signal down to down to the right, to the not carry signal header, which is what we're going to be doing. So that's the fix. That's the fix. All right. So here I'm just showing you that this is a scrap connector I have. It's not the one that I used, but I used this to prove out the repair. So what you're seeing here is, this is the not carry signal pin, and what I did was use 30 gauge wire wrap wire to wire wrap that around the pin, which I did, and then also put some heat shrink tubing over that, shrunk that down, and then bent the pin over. So the pin will no longer be being inserted through the backplane. It's going to be kept insulated from the backplane signals. Okay, and this is not the backplane, but this is just some scrap, a scrap board that I had. But once I did remove the connector, I put a little bit of electrical tape right over that connection. So it's just a little bit extra insulation to make sure that this connection is not going to be made from the connector, to the backplane, to the board. We want that to be insulated. Okay, and then this is the completed repair. So you can see that the connector is back in place. You can see here that the bent out pin is just showing through with the black heat shrink on it there. And then we have the 30 gauge wire coming down to our signal headers. So that's a good thing that we had that. So it's given us a place to do the repair. And then again, this is wire wrapped onto the not carry signal pin. And then you can see here there's a little bit of a gap here. So what I had to do was also put one washer here just to give this a little bit of room to enable, support having that pin being bent out. But that's really the extent of the repair. And then I kind of like having this wire have this air gap because just want to minimize the chance of crosstalk. And these are all our main control signals coming out of the control card. So we want to, I said that little air gap is probably good. And what I think I'm going to do is use some 3D tape here, here, and here, just to kind of better secure this line and maintain that air gap as well. That's pretty much what I'm going to do to complete that. And then here we are, our ALU is back in the backplane to do our testing. And you can see went through here and did all the tests, and all the tests passed, as well as I confirmed that that the not see out signal is not affected, is not affected by any of the regression testing that we do here to make sure there's no, that signal is completely separate. Okay. So I think that's all I wanted to show today. So just a quick update. So based on this, again, I think we are back on track and can continue with our backplane build out. And the next card that we'll be testing will be the registers card. And once that's passed, then I'm going to have to start soldering again some more backplane connectors to do the final three cards, I guess it is. But yeah, I'm really disappointed in myself that I didn't do that test. I'm not real happy that this line is here. And what I'm going to do is I'm going to build out the rest of the cards. I'm not going to implement any of the expansion cards, and I'm going to make a final choice whether or not I'm going to have this uh, correct that issue in the backplane design, and if I'm going to have another version of the backplane fabricated or not. But this is a very expensive board to have to do, so I'm not sure if I'm going to do that or not. But it's probably fine that we're going to have this little wire here. Once all the boards are in, the boards are going to be covering up that wire, and the whole thing will be in an enclosure. So it would probably be fine to remain that way, but it's just a little annoying. Anyway, that's it for today. Until next time, thanks for watching.